Again, so this accumulation function needs to absolutely be added to the original. It said that there were 30 insects. Take your answer, add it to 30, then you would be done. So the idea is that we take this function, it could be two possibilities. Either it could be the area underneath the curve, or it could be values that are being added along across a long period of time. We're taking every little instant of change and putting them all together. You add so many little bitty pieces of change, it actually looks like the same thing as area. So it's an accumulation function that we're going to add on to some initial condition. In this particular case, that initial condition was 30 insects. Number 15, super duper important. I'm giving you a picture and asking you to create some rectangles. Write justified rectangles. From 0 to 4, it says 4 of them. Here, here. The next one will be there. And finally, you have a rectangle all the way up here at the top. Because we're doing a right justified rectangle, we're going to be putting all those values together. Your first one was 1 by 2, 1. Your next area was 2.5 by, or excuse me, 1.5. Wow, tripping over myself. 1 by 1 point, or excuse me, 2.5. It's a struggle. 2.5. The next one gives you 3. Finally, the last one gives you 4. Those rectangles, add them all together, get your final value. How about a 10.5? It's all the work that you just did really quick. Letter B, it says, is this estimate greater or less than? Well, just check this out. Right here, you're overestimating by this amount. Overestimating the actual value every time by looking at this particular amount of space. Definitely greater than. And it's because f of x is increasing with right justified rectangles. That's important because if I changed from right to left, it would actually be an underestimate. If it was a decreasing function with these right justified, it would be an underestimate. So understanding what you're actually given is important. Let's talk about number 16. Gasoline is leaking out of a tank. Hourly measurements. I'm giving you a table. It says make 4 equal sized rectangles at the midpoint. The first rectangle would go from 0 to 2. But I would use the midpoint right here. Every time I want to use that middle number as the value in which my midpoint is calculated. The height for each rectangle is going to use the middle number, not the edge. So from 0 to 2, from 2 to 4, I'm going to use the value of 3. Then I'm going to use 5. And finally, my last rectangle has a height of 2.8. All those values will be added together. The common width for each one of these rectangles was 2. There's my answer. Remember, the AP says you don't actually have to do that calculation. You can leave it how it is. Closing in on the last couple of questions now. This is super important again. From 0 to x for h of t dt, the domain has to be from 0 to 12. Plug in your 4, figure out the area. That'll be the area that is shown right here in red. In particular, you can just count some boxes on this one. I see 6 full boxes. I've got an extra whole box over here on the far left side. That gives me a total area 7. All the way to 12. Now, the area that's up here is going to be negated by the area that's down here at the bottom. How much extra did you end up with? Well, if you want to keep score at home, you're going to end up with a value that's a low number. I don't remember exactly what it is right this second, but you end up with a negative blank. I think it's like 4.5 or something. Letter C. the absolute value, what the absolute value is again, what it's telling us to do is to break this integral into two separate sections. Take this second section, and instead of having it be negative, we're really asking you to flip it so that it's on the top, and it looks something like this instead. That doesn't exist anymore, not for that last question. So instead of subtracting it away, you're actually going to add on to the values that you had before. And let's keep it moving. Letter D, where is it increasing? Go back to the original picture. Remember, this graph tells you the derivative, which means that the derivative is going to be positive from 0 to 4.5. Where does it obtain its maximum? It's when it stops increasing and begins decreasing. That point is actually a maximum point, 4.5. Where does it obtain its minimum? Well, you got two different options. It's where it started going up from, option number 1, or where it finishes going down at 12. Which one of those is technically lower? Well, if I add an amount that's about 7 and I take away an amount that's about 12, that means this spot actually had to be lower no matter what. Is this concave up or concave down at x equals 0.5? Well, the slope of the derivative gives you that information. It has a positive slope, therefore this graph is concave up. And where would x equal 0? A of x has to equal 0. What's the integral that you're trying to make equal to 0? There is no area at the beginning. You add a bunch of stuff, and then you work your way back towards the bottom. Once you get to about right here, you have just reached that point in which the top area and the bottom area is completely canceling each other out. That happens exactly at 0 and 8.5. At 8.5, these two areas canceled each other out, which means that you're back at 0 again. That's a good place to be. Having said all that, hey, you're done. All that work took us about 23 minutes worth of work. This is everything that you need to know for your test. Again, this was the test from a couple of years ago. I have nothing but faith in you guys. If you have any questions, you feel free to email me. Otherwise, I will see you tomorrow. Bone Stone. I don't know if I'm talking anymore. Peace.